This video is going to cover what happens when we have tangents and secants intersect. First, let's go ahead and remind ourselves a tangent. Tangent is defined as a line that touches a circle at exactly one point. Tangent touches. Tangent touches, TT. It's just going to go by and just graze it, just hit it right there at that one point. Okay? So when we have two tangents that intersect, they can look two different ways. We can have the lines where they keep going on forever, or they can stop as segments. Okay? So these examples are not going to show your full tangent lines. When we name tangents, if we look over here, we want to name these tangents. We have line AB, and we have line CB. The tangent, when two tangents intersect, they are going to be congruent. Okay, no matter what's going on, we've got these two tangents. So our formula is simply going to be tangent equals tangent. So it might seem like, what? Well, let's take a look at, I guess I can keep these consistent, uppercase. You just set them equal to each other, guys. That's it. So example 1, these two are going to be congruent. So we're going to set that 2 parentheses 2x plus 1 equal to the 14. So here first we distribute. 2 times 2x gives us 4x. Distribute 2 times 1. Positive 1 will get plus 2, all equal to 14. We take our last two steps, subtract that 2 from both sides. 4x is going to equal 12. Divide both sides. X will equal 3. Plain and simple, set them equal to each other. So example 2, again, these are going to be congruent. So we're going to set this 2x plus 5 equal to the 3x minus 2. I'm going to move my smaller variable, subtract the 2x from both sides. Going to wind up bringing down that 5 equals, we only have 1x left, minus 2. Add 2 to both sides. X will equal 7. So that's two tangents. Now, secants, intersecting secants. We remember that a secant is defined as a line that touches a circle at 2 points. Okay, so it's going to slice. Secant slices. Okay, secant's going to slice through the circle and exit out another area. Okay, so when we have two secants that intersect, we see two different things here, like we did with the tangents. Some of them do not show the full secant lines extending. So over here, this should say secant. I changed it on our notes, but did not print up the new one. So this should say naming secants. We're going to name the two secants over here. So we have line DF. You can actually call it line DE, DF, ED, FD, any of those two letters you want. Okay, so we've got line DF, and again, same thing. You can use any of these two letters on this line in whatever order you want. I'm just going to call it line GF. So the formula now is going to be, and this is where you have to be careful with this formula, okay? This is going to be outside times total equals outside times total. And let's turn to the next page and see exactly what this looks like. And you bet I'm going to have my colors. I'm going to have 3 different colors. All right, so let's start with, we have outside times total, outside times total. So the difference between outside and total. Your outside is going to be right here, outside of the circle. So that's going to be a 3. Your total, you need to be careful, is the entire thing. all of it. So you're going to have to do some adding here. So your total is going to be 8. Now watch what happens with the next one. We have our outside of 4. And then the total, we are going to have to add these two together to give us x plus 4. Be very careful with that. It is not an x. It's x plus 4. You have to combine them. So on the left-hand side over here, we just do our multiplication, get 24. This is going to equal 4 distributed to x, 4x. 4 distributed to a plus 4 gives me plus 16. I'm going to subtract that 16 to get it away from x. I'm going to wind up with 4x equals, let me get that paused. Right, so we have 4x equals 24 minus 16 is going to give us 8. Divide both sides. X is going to equal 2. All right, so let's check out another one. Outside, right here, 4 times total. All right, we got that. We got to add these together again. You can do 4 plus x if you want. I like my variable first. So we have x plus 4. It looks a lot like the other one we just had. All equal to, outside on the other secant, 3 times, that is changing here, the total of 16. So here we distribute 4x plus 16. 3 times 16 is going to give us 48. Subtract that 16 from both sides. 4x is going to be equal to 32. Then we divide. X is equal to 8. Okay, so just be careful with that total. You have to add them together. Okay, please don't forget that. Now, we looked at 2 tangents intersecting, 2 secants intersecting. Let's look what happens when one of each intersects. This is what we end up looking at. Okay, majority of the time you're going to have it without the extensions, like the one on the right or here. Okay, now we want to name the tangent and name the secant. Well, here the tangent is going to touch, barely touch. So over here we're looking at line LK. It barely touches, just at one point. And the secant is going to slice through. Secant slices. So we have line IK. And again, you can use any of those 3. You can use any 2 of these 3 points on that line. So now we're going to see a little bit different, a little bit the same going on with the formula. When a tangent and a secant intersect, you're going to take the tangent squared, and this will be equal to what we just saw earlier, outside times total. Okay, so you're still got to pay attention to the outside times total. So this first one we solved for x, our tangent. We need to see our tangent is the one that does not go inside the circle. So we have our tangent squared, so we have 15 squared. I guess up here, let's fix this formula, just in case there's variables with it squared on the outside. So 15 squared equals outside 9 times the total. All of it, add them together, x plus 9. When we square 15, we're going to get 225. We're going to distribute to 9x plus 81. Subtract that 81. We're going to get 9x equals 144. Oh, yeah, 144. Then we divide both sides by 9, running out of room. X will equal 16. All right, last one. Tangent, the one on the outside, squared. So we have x squared. This will be equal to, again, outside here at the very, very top, outside 4 times total, the entire thing. Add those together to get 9. All right, so our x squared just stays as x squared. 9 times 4 is going to give us 36. So again, we had this x squared. We just saw this in a previous problem notes. We need to get rid of that. The opposite, the inverse of squaring is square rooting, that radical sign. Square root of 36, x is going to equal 6.